Cymatic music is an ongoing sound, art and science project exploring patterns of vibration. Patterns we can hear, that is to say music, and sonic patterns we can see. Now, how can we see sound? Well, when a physical matter is vibrated with sound, certain geometric symmetries are manifest. And this field of inquiry is called cymatics. Hence the name of this project, Cymatic Music, where my aim is to develop a creative bridge between the basic principles of music and those of cymatic phenomena. Here, a dish of water is vibrated with a low-frequency sine wave. As the volume is increased, the circular ripples transform into a dynamic pattern with five-fold symmetry. To appreciate the intricacies of this patterning fully, the footage can be slowed down. And the waveform viewed from above. If the frequency of the sound source is increased, a myriad of different cymatic symmetries can be coaxed from the water. Threefold, fourfold, twofold, and fivefold symmetry. The progression of these symmetries proceeds in an ordered periodic fashion as shown in this graph. This wealth of evolving cymatic forms constitutes the source material for a series of short films I've created with the video artist Gregory McNeely. Like a dish of water, a string can vibrate in distinct periodic modes. These are known as harmonics. The fundamental first harmonic, the second harmonic, third harmonic, fourth harmonic, fifth harmonic, sixth harmonic, seventh harmonic, and eighth harmonic. Each tone an integer multiple of the fundamental frequency. We can map this series onto a grid and add the mathematical inverse, the subharmonic series. The half, the third, the fourth, the fifth, the sixth, the seventh, and the eighth of the fundamental frequency. Each note of this series can in turn be taken as the fundamental of a different harmonic series. The resultant matrix of proportional tones is called a lambdoma and is the cornerstone of a musical architecture called harmonicism. And if we are to find a common language that links music and cymatic phenomena, this seems an appropriate system to adopt. Furthermore, in order to explore the tonality of this different sound world, I've had to design and build some new musical instruments which can be heard in the films I mentioned earlier. The harmonic canon, the harmonic flute, and the harmonic guitar. To what extent, then, does cymatic patterning correlate with proportional harmonicism? Does matter vibrate harmonically? Can we see what we hear? In the case of spherical media, such as bubbles, the answer is yes. The pulsating symmetries of these bubbles directly reflect the rhythmic tones of the harmonic guitar. Other vibrating media show intimations of harmonicity, but at this stage their musical accompaniment is largely interpretive.